Good morning, students. Welcome in new lecture of Math F242 Operation Research. So presently we are doing the chapter Dynamic Programming, the last chapter. So last time I have introduced you about the cargo loading problem, flyaway problem or knapsack problem, which we can solve through the dynamic programming. So in that you have seen in formulation we have the linear program. Audio is okay?
Sir, your screen is invisible. Just blank.
Just wait a bit. I think now okay.
Yes, sir.
So last time we have seen we in formulation of the knapsack problem, cargo loading or flyaway problem, we have the linear program and we have solved the linear program through the dynamic programming. So let us take another linear program. Just directly I'm taking the linear program. So solve the following problem by dynamic programming. Use backward recursion approach. Backward recursion approach means first we have to solve for the stage 3, then for the stage 2, then stage 1. Right. So let us have this problem. Maximize z is equal to 20x1 plus 50x2 plus 60x3 subject to x1 plus 2x2 plus 2x3 less than equal to 15 and x1 greater than equal to 3, x2 greater than equal to 2 and x3 greater than equal to 1. So if you compare with the knapsack problem, it will become the maximize z is equal to R1 M1 plus R2 M2 plus R3 M3 subject to W1 M1 plus W2 M2 plus W3 M3 less than equal to capital W and M1 greater than equal to 3 M2 greater than equal to 2 and M3 greater than equal to 1. So in the dynamic programming, always we decompose the problem into sub problems depending over the number of variables. So here we have the three variables. So stage 1 dedicated for the x1 variable, stage 2 dedicated for the x2 variable, and stage 3 for the x3 variable. So for each stage, we have to define the state variable. So here we define the state variable. Let yj j is equal to 1 to 3 be the state variable for the stage j. Means yj represent whatever you are allocating, right? Means yj represent whatever you are allocate y1 represents whatever you are allocating for the x1 x2 x3. Y2 represent whatever you are allocating for the stage 2 and stage 3, and Y3 represent whatever you are allocating for the stage 3. So state variable is the variable which combine all the stages. Then after we define objective function, right, for each stage. So here we have the stage 3. So when we are defining the objective function, when we define the objective function, at that time we have to check what is the function, and we have to check the feasibility condition also.
Sir.
So yes.
Sir, how do we know that this is an integer programming? We considered only integers here. So, is it
Okay, it is not written, but you assume that it is of integer programming, right?
okay?
you assume this in this question. Your observation is correct. Presently, it is from the question. It is not observable. Ki it is integer programming problem. But here we are doing only the integer programming problem. But till now, I have not covered the continuous one. Right. So here in the stage 3, we have to define the objective function. So it means we define the objective function for the stage 3 F3 depending over the state variable Y3. So what is the basic formula? Basic formula is the R3 M3 plus Fn plus 1 of Yn plus 1 means F4 Y4. And you know that there is no stage 4. So always this is equal to 0. So this will become R3 M3. And for the given question, R3 is given to you. R3 is given to you as a 60. R3 is given to you as a 60. So it will become the 60x3. Right? 60x3. So here we write the 60x3. So it is the F3Y3. F3Y3. Now, what is the feasible range for the X3? So feasible range for the X3, that is very important in this question. Knowingly, I have chosen this question. So please listen carefully how we are writing the range means feasibility condition for the Y3 and X3. So here, what is the given condition? Please listen carefully. Right? It is given to you X1 should be greater than equal to 3, X2 should be greater than equal to 2, X3 should be greater than equal to 1. It means minimum space you require, right? If the unit weight is 1, 2 and 2, if unit w1 w2 w3 are 1 2 2 respectively, and minimum number of items you require 3 2 1 respectively. So minimum weight you require 3 into 1, 3 into 1, correct, 2 into 2, correct, and 1 into 2. So minimum weight you require the 3 plus 4 plus 2. So total 9. So minimum with the minimum condition, minimum weight you require is the 9. It means you have the choice of the 6 only, because maximum weight is 15. So you have the choice of the 6 for the alternatives. So that 6 we have to decide. So now listen again. When we are allocating the item 3, means X3. So here the unit weight is what? Unit weight is the W3 is the 2 unit. So minimum 2 unit space you require. If you have the space of the 0 or 1, you cannot accommodate the minimum quantity of 1. X3 greater than equal to 1. It is requirement that X3 greater than equal to 1. So in the empty space of 0 1, you cannot accommodate, you cannot allocate one item of 2 unit weight, right? One item of 2 unit weight. So for allocating the 2 unit weight, one item of 2 unit weight, minimum 2 units you require as an empty space. So that's why I have started this as a 2. Right? In the table, in the Y3 column, I have started with the 2. Then after, if you have the space of the 3, then also you can allocate only one item. So whether you have the space of 2 or space of 3, you can allocate only the 2 items, right? You can allocate only one item. If you have the empty space of the 2 unit or 3 unit, you can allocate only one item. If you have the space of 4 or 5, then you can allocate 2 items of 2 unit weight.
Sir,
If you have the space, yes.
So your x3 should be equals to 1, 2, 3, right? Not 4.
4 you require na, when we have the space of the 8.
So I'm talking for x3. Like x3, capital W will be 6 now. So 6 by 2 it is 3. So 1,
No,
2,
no,
3.
where it is the 6? It is the 15.
But the minimum 9 is required. So we are removing that.
I'm coming. I'm coming. Just you
Okay.
wait. If you have the doubt, I will clear all the things.
Okay, sir.
Just let me finish, then you ask your doubt. I will finish. I will continue with that your doubt. So if you have the empty space of the 6 unit and 7 unit, you can allocate maximum 3 item of 2 unit weight. Correct? Now if you have if you have the space of the 8 units, right? If you have the 8 units, then you can accommodate the 4 items, right? 4 items of 2 unit weight. Clear this part? Now why I have stopped here the 8, up to the 8 only? Because 9, 10, 11, 12, 13, 14, 15 are required for accommodating the item 1 and item 2 in stage 2 and stage 3. So what is the minimum requirement? Minimum requirement is in stage 2 we accommodate minimum 2 items of type 2, right? Minimum 2 item of type 2 whose weight is a 2. It means total weight required is a 4. Total weight required is 4. And in stage 1 we have to allocate minimum 3 items. Minimum 3 items whose unit weight is the 1 unit. So it means 3 units space you require. So it means for accommodating item 2 and item 1 in stage 2 and stage 1, minimum 7 unit you require. 4 for the 4 for the type 2 item and 3 for the type 1 item. So total space, so it means this 7 unit you cannot allocate for the stage 3, right? This 7 unit you cannot allocate for the stage 3. So now your doubt is clear.
Yes, sir.
So here now x3. So here we have written the y3 as a 2, 3, 4, 5, 6, 7, 8. And now we are talking about the x3. What are the alternatives? So here we are writing the alternatives. Alternatives means we have the space of the 2, 3. Then we have the alternative of 1 only. If we have the space of 2, 4, 5, then we have the alternatives of the 1 and 2, because unit weight is 2 unit. Correct? When we have the space of the 5, 6, 7, then we have the choice of the 1, 2, 3. So that's why whatever the feasible things that I am writing in the table. So x3 can be 1, 2, 3, 4, and corresponding objective value f3 value, function value, objective function value f3 y3 will become 60, 60, 60, 120, 120, 120, 120, 60 into x3, 180, 180, and then 240. So maximum, it is the question of the maximum. So maximum objective value will be the 60, 120, 180, 240 corresponding to state variable 2, 3, 4, 5, 6, 7, and 8 respectively. And these objective value you are getting when we are allocating 1 item, 2 item, 3 item, 4 item of type 3 in stage 3. This table is clear. Then only I will proceed for the stage 2. Any entry you want to re-explain? Clear? Can I move?
Yes, sir.
Now, we talk about the stage 2. So in the stage 2, we have to define the F2Y2. What is the basic formula F2Y2? It is the R2 M2 plus F3, right? F3Y3. F3Y3. Now, because right hand side is the function of Y2, so left hand side should also be the function of the Y2 only. So it can be written as R2 M2 plus F3. Now Y3. What is the Y3? Y3 is what? Whatever you are allocating in the stage 3. In the stage 3. And Y2 is what? Whatever you are allocating in the stage 2 and stage 3. So how much you are allocating in the stage 2 or stage 3? In the stage 3, you are allocating in the stage 3 you are allocating the 2x3. So it will be the in the stage 3 you have allocated the 2x3, right? So y2 means y3 is equal to y3 is equal to it is a 2x3, right? Means you can say, let's say it is the y3, means whatever you are allocating in stage 2 plus allocation for the stage 3, so it is the y3. So y3 will become, yes, y3 will be the
Y2 minus
whatever you
2x3.
have, yes, whatever you have for the stage 2 and you have allocated right here. So how much it no you have allocated the x in the y2 you have allocated the 2x2 in the this you have allocated. So what is the y3? So y3 will be the 2x2. In the question it is given now. In the question it is given to you x1 plus 2x2 plus 2x3. So you have allocated in the x2 as a 2x2 only. So y3 will come the y2 minus 2x2. So when we write this, so this is the objective function for the stage 2. So here in the stage 2, we have the objective function R2 M2 means 50x2. If you let's see the question, it is the 50x2 for the stage 2. 50x2 plus f3y3, and f3y3 can be written as y2 minus 2x2. So any doubt in writing the function? Any doubt in writing this function? Now what is the value of the y2? So how much space you require for the minimum allocation in the stage 1? So in the stage 1 you have to allocate minimum 3 items of type 3 of 1 unit weight. So for fulfilling the minimum criteria you require minimum 3 unit space. So here we require the 3 unit space. And for fulfilling the stage 3, how much space you require for fulfilling the minimum criteria? So that you require the means minimum 1 item of unit weight 2. So here we require the space for the 2 for the stage 3. And for fulfilling the minimum criteria of stage 2, x2 greater than equal to 2, you require the space of the 4 unit, because unit weight is the 2 unit. So here we require the 4. So total how much space you require for the stage 2? For the stage 2, total you require the 6. That is important here. You cannot write the space from 0, 1, 2, 3, 4, 5, because in that you cannot fulfill the minimum criteria. So you have to start this y3 from the 6 and you have to stop at the 12. Then because the unit weight is 2 unit, so when we have the space of the 6, you can allocate minimum 2. When we have the 7, then also you can allocate minimum 2. When we have the space of the 8 and 9, then you can allocate minimum 2 or 3. When we have the space of the 10 and 11, then you can allocate minimum 2 or 3 or 4. When we have the space of the 12, then minimum you can allocate 2, or we have the choice of allocating 3, 4, 5. So x2 can be the 2, 3, 4, 5. 2, 3, 4, 5 for the y2 is equal to 6, 7, 8, 9, 10, 12. Clear this part? Now, when the x2 is equal to 2, right? When the x2 is equal to 2 and y2 is equal to 6 or 7. 6 or 7. So when the y2 is equal to 6, and x2 is equal to 2, so it will become the 2 into x2, that is the 4. So 6 minus 2. So f3 of 2. So f3 of 2, it is given to you as a 60, right? f3 of 2 is given to you as a 60. So 50 into 2 plus f3 of 2, that is the 60. So it will become the 100 plus 60. Similarly, when we have the space of the 7, then also we have the 100 plus 60. So in this way, we can write. For example, let's see this one, or you can say, let's say this one, right? So when the x2 is equal to 3 and y2 is equal to 12, so y2 is equal to 12 and x2 is equal to 3, so it will become the 50 into 3, that is the 150, right? That is the 150 plus y2 is equal to 12 minus 2 into 3, so 12 minus 6, that is the 6. So f3 of 6. So f3 of 6 from here, it is the 180, right? It is 180. So here we write the 180. This 180 we write here. So the optimal value of objective function 2 corresponding to state variable y2 are 160, 220, 280, 340, and it is corresponding to alternatives 2, 2, 2, 2, 2. Clear this part? Now, for the stage 3, means, or for the stage 1, for the last stage, because we are doing the in the recursive. So for the stage 1, now what is the objective function? So objective function for the stage 1 will be, so objective function for the stage 1 will be the f1 y1. What is the basic formula? r1 m1 plus f2 y2. So in this case, what is our r1? R1 is given to you, right? R1 is given to you 20 x1. So it will become 20 x1 plus f2. Now we have to write. So here, what is the state variable y1? Whatever you are allocating corresponding to x1, x2, x3, and what is the y2? Whatever you are allocating corresponding to x2, x3. So how much you are allocating in the stage 1? So you are allocating in stage 1 means y2 will be the y1 minus, in stage 1 you are allocating 3x1. Why the 3x1? right? Y3x1, because in fulfilling the minimum criteria, in fulfilling the minimum criteria, x1 should be greater than equal to 3. Minimum number of items required is the 3 of unit weight 1. So it will become the no, no. So total number of the weight, we have the x1. So it will become the y1 minus x1, right? It will become the not 3, that we have to allocate. So means corresponding to x1, how much item we are writing. So y1 minus x1. So it will become the 20 x1 plus f2 of y1 minus x1. Then after, so maximum of the 20 x1 plus f2 of y1 minus x1. Now, how much? What is the range of the y1? So range of the y1 means it must satisfy the minimum criteria of all stages. For the stage 3, how much space you require? 2 ton. For the stage 4, how much space you require? 4 unit. And for the stage 3, how much weight you require? 3 unit. So minimum units you require will be the 9. So here we write the y3 range from the 9 to 15. 9 to 15. Then after, what is the range? What is the value of the x1? Since x1 is of unit weight 1, minimum 3 units you require. So it means x1 can range from the 3 to 9. X1 range from the 3 to 9. So naturally, always you get the optimal solution when you utilize all the space. So instead of showing for the all y1s 9, 10, 11, 12, 13, 14, 15, we can just show for the 15, whatever the maximum limit. Need not to show for the 9, 10, 11, 12, 13, 14. So just show for the 15, because when you utilize the complete space, then only you will get the optimum revenue. So when we have the 9, y1 is equal to 15, x1 is equal to 3, 4, 5, 6, 7, 8, 9. So corresponding objective values are given to you. So here maximum revenue we have 400, and 400 you are getting from here. So when x1 is equal to 3, so when x1 is equal to 3, then you are getting the maximum 400 revenue. It means now we are allocating. So when initially we have the space of the 15 unit, for the 15 unit you have the optimal answer, means you have to select the 3 items of type 1 whose unit weight is 1. So x1 is equal to 3. So when x1 is equal to 3, it means you have used the 3 unit space. So remaining space will be the 12. Remaining space is 12. So corresponding to 12, now x2 is equal to 2. Corresponding to 12, x2 is equal to 2. So x2 is equal to 2. It means 2 items of type 2 of 2 units weight. So 4 units you have used out of the remaining 12. So now we have the remaining 8 units. Corresponding to 8 units, right? Corresponding to 8 unit. So in the stage 3, if you check, corresponding to 8 unit, we can select the 4 items of type 3. So here the x3 is equal to 4, and optimal value of the revenue will be the 400, whatever here you are getting. So in this way you can solve any linear program also. Now anything you want to ask? Yes, anything, any slide you want to ask? Yes, anything corresponding to a state variable, decision variable, stages, objective function, alternatives.
Sir,
Yes.
sir, in this case, all of the solution, all of the cases they are coming at the highest value of y1, y2, and y3. So
No,
this
it is not necessary. Means it is not
okay.
necessary.
So this
By
method
chance,
we can only use
by
in
chance
the
for this question it is
stage.
coming, but it is not necessary.
So maximum allocation for y1 we can only do in stage one.
What is the maximum allocation means?
Means y1 maximum value we can only use in stage one. Like we don't have to use
Only in
9.
stage one. Only in stage
Okay.
one. When we are doing the recursive method, then only in stage one. When we do the forward method, then in stage three.
Okay.
When we are allocating, initially we have the empty space. Now whole vessel is empty.
Yes,
With
sir.
one item you can fill completely. Now
Yes, sir. Okay.
with that logic we are allocating the 15 only. Because initially when we start the allocating, then we have the complete space. So with first item only we can fill. Might be it give the maximum revenue. There is no need for taking the second item or third item. Here we have the restriction, but might be there, if there is no restriction, then there is no need to take any other means item 2 or item 3. Clear?
Yes, sir.
Now exactly similar type of the question. A wilderness hiker must pack the three items: food, first aid kit, clothes. When three items he wants to take in knapsack. The backpack has capacity of the 3 feet cube volume. There is the maximum limit of the volume. Each unit of the food take 1 feet cube. A first aid kit occupy 1 by 4 feet cube, and each piece of the cloth takes about half-feet cube. The hiker assign the priority weight 3, 4, 5 to food, first aid, and clothes, which means the clothes are most valuable of the three items. From experience, the hiker must take at least 1 unit of each item. Means one packet of food, one packet of first aid, and one cloth of each item. No more than two first aid kits. Means not more than two first aid. Here we have the upper limit of the first aid kit also. How many of each item should hiker take? So in this case, let's define the question where decision variable x1, x2, x3, number of food item, number of the first aid kit, and x3 as a number of the cloth pieces. So from the question, because you want to maximize the valuability, so maximize z is equal to 3x1 plus 4x2 plus 5x3. Right here it is written the priority weight. So 3x1 plus 4x2 plus 5x3 subject to x1 plus 1 by 4 x2 plus 1 by 2 x3 less than equal to 3. Why we have written this? Because maximum volume limit is the 3 feet cube, and unit weight corresponding to food, corresponding to first aid kit, and corresponding to cloth are these. So we can write like this, and minimum criteria is given to you that x1 should be greater than equal to 1, x2 should be greater than equal to 1, greater than equal to 1, but less than equal to 2, but less than equal to 2, right? And x3 must be greater than equal to 1. So always, in the dynamic programming, we decompose the problem into sub problems, and each sub problem is dedicated to the individual variable. So first, for the first stage we have the x1 variable, for the second stage we have the x2 variable, for the third stage we have the x3 variable. Now for the each variable, for each stage, there must be the common criteria, right? With that we define the state means how much we are allocating corresponding to x1, x2, x3 in stage 1, stage 2, stage 3. So here we define the state variable yi, the volume assigned to item I plus 1 and n. So what is the recursive equation? So for the stage 3, recursive equation will become R3M3 plus F4, right, plus F4, or you can say means 5x3 plus F4 y4, and F4 y4 is what? It is the 0. So it will become the 5x3. What is the alternatives? What are the alternatives corresponding to x3? Minimum x3 required is 2. Maximum how much you can allocate? You can allocate by because unit weight is what? Unit weight is the half. When the unit weight is the half, it is mistake. It will be the y3 upon 1 by 2. Y3 upon 1 by 2, because unit weight is given to you as a half, right? Then after F2 will be the what? It is the 4x2 plus F3, right? F3 of y3, and F3 of y3 can be written as F3 y2 minus x2 minus 4, because in the stage 2 you are accommodating how much space? 1 by 4 into x2, 1 by 4 into x2. And what is the range of the x2? X2 will be the from 1 and minimum of 2 or y2 upon 1 by 4, y2 upon 1 by 4. Clear this part? Then f1 y1 will be the maximum of the x1, 3x1 plus f2 of y2, and f2 of y2 can be written as f2 of y1 minus x1, and here 3 and range for the x1 will be the minimum 4 and maximum whatever the space of the y1, because unit weight is 1. So 1 to y1. So only the main thing means all the information about the state, alternatives are here. Then after we have to make the dynamic table for the each stage. Anything you want to ask here? It is visible or I have to enlarge?
It's visible, sir.
Anything you want to re-explain here? Then we have the just table. So for the stage 3, in the stage 3, you know unit weight is what? Half. Unit weight is half. So for the accumulating or for allocating the minimum one item, you require minimum 0.5 unit space. So when we have the 0.5 unit space or 0.75 unit space, you can allocate only one item. When we have the space of the 1 or 1.25, then you can allocate to 1 or 2 items. When we have the space of the 1.5 and 1.75, then you can allocate either 1, 2 or 3 items, right? 1, 2, 3 items. So in this case, actually, this we have not to write, right? This we have not to write. There is no such allocation. Now, it means here we require the space of the 0.5 for the minimum, for satisfying the minimum criteria, and for satisfying the minimum criteria for the stage 2 and stage 3. For the stage 2 and stage 3, how much item you require? How much space you require? Minimum you require for the stage 1 and stage 2 is the 1 and 1 by 4. 1 and 1 by 4 means 1.25. So minimum you require 1.25. So when minimum 1.25 you require for the stage 1 and stage 2. So for the stage 3, maximum you can have 1.75. So that's why I'm writing here 1.75. Then for the stage 2, for the stage 2, for the allocation in stage 1, minimum you require the 1 unit. Minimum you require the 1 unit. Right? Here you require the minimum 1.25, 1.25. Right? But here you require minimum 1, minimum 1. Clear this part? Minimum 1. And for the 1 item of item 3 and item 3, item 2, you require here half and here 1 by 4. Right? Half and 1 by 4. That's why minimum is the 0.75. So 0.75, 1, 1.25, 1.50, 1.75, and maximum 2. And we know that X2 can take minimum value 1 because at least one item require first aid kit. X2 is the what? First aid kit. And maximum 2 you require. Maximum 2 you require. So we take the X2 is equal to 1, X2 is equal to 2. And corresponding value we are writing here. So it will come a y2 minus x2 upon 4, right? Y2 minus x2 upon 4. 1 minute. I think I have a. Here I have done correct. No, right. Here I have done the correction. Here it is correct. So it is the y2 minus x2 upon 4. So using this function, we have the value. We have the value 9, 13, 14, 18, 19, 23. So you can see here, it is not necessary always from the same column we have the optimal value. So we have the 1, 2, 1, 2, 1, 2. Few from the column 1, few from the column 2. Then the stage 1. In the stage 1, because you have the complete volume, right? So here you can say it is a 3, and x1 can take the value 1 and 2. Right? Why 1 and 2? Why 1 and 2? Why not 3? Because unit weight is the 1. Unit weight is 1. Right? Unit weight is 1. So why not 1 to 3? Why only the 1 and 2? Yes. Because 1.75 space you require for the first aid and cloth also. So maximum you can have 2.25. In the 2.25 you can have the choice of the 1 and 2 only. So after writing this, so initially we have the y3 is equal to y1 is equal to 3. So y1 is equal to 3. You have to take the one food. So y2 will be the 2. So when y2 is equal to 2, so here we have the 2. So it means you have to take away 2 first aid kits, right? So when we have the 2 first aid kit, so y1 will be the 1.5. So when the y1 will be the 1.5, so it will become you have to take the 3 items. So 3 of cloth. So total revenue or total value from the item will be the 26. So that is the optimal allocation. That is the optimal allocation. Now solve the following model by the dynamic programming. Maximize z is equal to maximize z is equal to y1 y2, or instead of the y1 y2, just wait a bit. Yes, instead of the y1 y2 you take the x1 x2 x1 x2 xn. They are in product, subject to x1 plus x2 plus xn is equal to c, and all the xi greater than equal to 0, or all the xj greater than equal to 0. This is the question. So in this, in the objective function, what we have? We have the product, and in the constraint we have the sum. In the previous questions, whatever the linear program till now we have done, so in all, this is the non-linear because of the product, it is a non-linear, but in the linear program whatever we have done till now, in that the objective function and constraint both are of plus nature, sum nature, but here we have the objective function product and constraint as a sum. So let us start to solve. So again, what we have to do, we have to decompose the problem into variable, right? We have to decompose into the n stage. In each stage we have one variable. So let's say yj, the portion of the quantity c allocated to variable j, j plus 1 and n. So it means when we have x1 plus x2 plus xn, right? This much you have to allocate. So for the stage in the stage n, how much you will allocate? You will allocate the xn. In the stage n minus 1, how much you will allocate? Xn plus xn minus 1. In the stage n minus 2, how much you will allocate? Xn, xn minus 1, xn minus 2. Similarly, in the stage means when we have the y2, so how much you will allocate? X2, x3 and xn, and when we have the y1, then it is the x1, x2 and xn. So in this way we have the relation between the decision variable and the state variable, decision variable and the state variable. So from here also you can write. So what is the, for the stage n, what is the f and yn? F and yn is maximum of the xn, maximum of xn, because we have only the one variable, and xn can take how much value? Xn can take how much value? Whatever the remaining one. So xn cannot be more than yn. So here we have the xn less than equal to yn of the xn, of the xn. So naturally when we have the linear function x, so when it takes the maximum value, it takes the maximum value at the right boundary of the limit, right? On the right bound of the interval. So it means it takes its maximum value will be what? It is the yn, right? It is the yn. So when the state variable is yn, so function maximum value will be the yn corresponding to xn is equal to yn. Clear this part? Means I am saying that you have to maximize. X can take the value, right? X can take the value up to the 5. So where we have the maximum value? At 5 only, right? So that is the logic. Now for the stage n minus 1, for the stage n minus 1 means now we have to write the objective function. So for the stage 2, for the stage n minus 1, what is the objective function? That is the that is the xn into xn minus 1, xn into xn minus 1, or xn minus 1 into optimal value of nth stage, optimal value of the nth stage. and this yn can be written as y from these two. Yn can be written as from here, from these two relation, yn can be written as, please tell me, hurry up, time is going on. So xn minus 1 fn of yn can be written as, yes, now
yn
you
minus
have,
1 minus xn minus 1.
yes, right, from these two you can write easily. Now I have written here clearly. So it is the yn minus 1 minus xn minus 1. So that's is written here. So it will be the fn of yn minus 1 minus xn minus 1. And now when it takes the maximum value, it takes the maximum value because it is what? Means what is the maximum value of the fn bracket? Right? Maximum value of the fn bracket is the bracket. Right? Maximum value of fn bracket is the bracket. So it will become xn minus 1 into yn minus 1 into minus x minus 1. Right? Fn of bracket is the bracket. So fn will be the, it is written here. So our objective function will be this. So you know that it is the equation of the parabola, right? So if you take its derivative with respect to, we have to optimize, right? So if you take the derivative with respect to yn minus 1, so it will become with respect to xn minus 1, right? With respect to xn minus 1, if you take, because we want to maximize the value of the xn, so it will become yn minus 1 minus 2 into xn minus 1 into 2 yn minus 1. And you know that from the calculus it is equal to 0. So here the xn minus 1 will become xn minus 1 will become the yn minus 1 upon 2, right? Yn minus 2, because here we have it is the xn yn, it is the xn, right? So xn minus 1 will become the yn minus 1 upon 2. So that is written here. And when we put this value, yn minus 1 upon 2 in this in the fn minus 1, so this is when here you put the value of xn minus 1 as a yn minus 1 upon 2, so you will get the yn minus 2 upon 2 whole square, right? That is the optimal value. So by induction, if you talk about the jth stage, so for the jth stage, the optimal value of the xj will come this, and right, optimal value of the fj is coming this, corresponding to xj this. So when you start the allocation, so you have to start in the similar way. So for each xj we have to allocate c upon n, and maximum value will come c upon n into c upon n into c upon n into c upon n, that is the c upon n power n. So here we have the means non-linear program also through the dynamic program.
Excuse me, sir.
Yes.
Sir, here fj yj would be xj times fj plus 1 of yj minus xj plus 1, right?
Here what you are saying, this here you are asking,
Yes, sir.
it is the fj plus 1 yj plus 1, and what is the what is the, here we have the yj and yj plus 1. From here you can write na yj and yj plus 1. So yj is what? xj plus 1 plus xn, and yj plus 1 is xj plus 1 xj plus 2 plus xn. So when you subtract these two, so you will get you you will get the yj plus 1 as a yj minus xj.
Sir,
Clear, or I have to?
but for j equal to n minus 1, we got y n minus 1 minus xn. So similarly,
xn
it
no.
will work, right?
No,
Yes,
no,
sir. That's
xn minus 1. We are getting the xn minus 1,
okay. Sir.
not xn minus 1. I have to demonstrate. Just wait. Just wait. What is the definition of the yj? Yj means xj, xj plus 1, xj plus 2, xn minus 1, xn. Whatever you are allocating for in the stage j plus 1, stage n. What is the yj plus 1? That is the xj plus 1, xj plus 2, xn minus 1, xn. So from these two, what is the yj minus yj plus 1? That is only the xj. So from here, yj minus xj is equal to yj plus 1. Now clear?
Yes, sir. It's clear.
I think now clear.
Yes, sir. It is clear.
Any other doubt? So in this question, instead of the n variables, we can give for the 3 variables. Means we can give maximize y1 into y2 into y3 subject to x1 plus x2 plus x3 is equal to 3 is equal to 6 is equal to 4, anything number we can give. So what is the optimal value of the xis? Any other doubt? So this is the optimal formula.